Welcome back. Today we are going to see about Apache Kafka architecture with ZooKeeper and in the KRaft mode. Before Kafka 3.x, ZooKeeper was there, and after 3.3, the Apache Kafka is the KRaft mode. So we will see that thing what is the different. The main components are same. Both has producer, both have consumer, both have Apache cluster. All the other main components are same. Only the changes is here it use externally ZooKeeper cluster, which is an external node, where KRaft controller use the system inside the Apache Kafka itself. We don't need any external node. So what is a producer? Producer is a message where the message will be created in one of a Spring Boot services. The consumer here also another service which consume the messages shared from from the producer. Producer send messages to whom? The producer publish the message to the broker, and the consumer consumes the message from the cluster. So what are the cluster has? The cluster has broker, and inside the broker we stored all the messages under a topic. The topic will have several partition. In the several partition, we'll have one partition as a leader and other will be the follower. We also will have a replication. Based on the replication counter configured, the topic name, the partition number, the number of partitions and the replication counts can be configured in the when we create a topic in the cluster. So in this example architecture, we are having three topics: order, payment, and inventory. So in here inside the consumer, we have a consumer group. Where the consumer group is created, consumer group is created and maintained in broker, but the group name is defined from the consumer. I'll explain that later. So producer consumer will write messages to cluster, read messages from the cluster. It doesn't aware about who is the producer, who is the consumer between them. Okay, here why we need ZooKeeper cluster or KRaft controller core to store metadata operations. What is metadata? Metadata is nothing but what are the broker I have, what are the cluster IP I have, who is my leader, what is my topic configuration, what is my consumer offsets. So all the information which I want to read and write, metadata information will be available in the ZooKeeper cluster. Similarly, in KRaft control quorum, all the details such as all cluster metadata. All cluster metadata is what is my IP, who is my leader, what is my partition details. All this information will be available in the KRaft control core. So these are the main information that is available here. So we are now very clear. If you want to introduce any broker, we can introduce the broker. All the details will also be replicated here. So this is the basic architecture of Kafka. The next one comes the Kafka message model. So what is the Kafka message? So when a producer sends a message, it has the message topic name with the message key. Based on the message key, it identifies which partition needs to be stored. So in a Kafka cluster, the topic orders will have multiple partitions with the message offset. You can see partition 1 have 0, 1, 2, 3, 4, 5. So we have 5 messages. So a message can be uniquely identified from these three: topic plus partition plus offset number. So you can see that here very clearly. So partition 0 will have a 0 message, and order 101 created or updated some example messages here. So We know already the producer sends the message, Kafka cluster stores, and the topic will be consumed by the message. So, how offset is assigned? For example, if the partition already have 0, 1, 2, 3, when the other next message will come, it will just sequentially increment the next offset as a 4. So, it finally go and store the next message as a 4. Consumer reads using offset. So consumer knows what is the last committed offset. So the next committed offset will be moved based on that. These metadata, all these metadata only stored on the craft. That is the main thing. Which last committed offset and which is the next message configured. That one. Multiple consumer groups. For the same topic, we have multiple consumer group. Why? Because consumer group A, inventory service, will read from partition 1. Consumer group B, analytics service, can be read from partition 1. Consumer group C can be read from partition 2. So 0, 1, 2 can parallelly read all the orders message parallelly using this consumer group. So, for example, if it is just a call detail record, one of a topic as a CDR where the partition is number is 2 and the offset. So, when the message is sent with the detail, this is the unique identifier to identify which message, how it is stored. So, what is the key takeaway? Every message has exactly one topic, one partition, and one offset. That is the message model. Offsets are uniquely only within a partition, not across the topic. Combination of topic plus partition plus offset identifies the message. That is the main thing here. It is reflected. Offsets are assigned by Kafka, not by the producer. Producer doesn't know what is offset itself. Consumer use offsets to track their position. Consumer uses the rhythm where what it reads, what how want further wants to read. All these things offset used by consumer. Okay. Always consumer fetches the data from the cluster. It doesn't, cluster won't push the data, consumer fetches it. Okay, that is the main thing here. So this is the architecture and message model of Kafka. If you need any questions or clarification, please let me know. Thank you all. We'll see you in the next session. Bye.